Hey class, welcome back and welcome to week 3, module 3 for chapters 3 and 4. Chapter 3 is on evolution, biodiversity, and population ecology. It sounds like a lot, but let's just break it down. Evolution is simply a change in populations of organisms from generation to generation, often leading to modifications in behavior or appearance. Okay? Natural selection is in your book as well, and it's like nature selecting for the fastest runner or the tallest giraffe. For example, if lions are chasing humans, the ones most likely to survive, reproduce, and pass on their genetics are the fastest runners. The giraffes, on the other hand, that are most likely to survive and pass on their genetic material are the ones that are the tallest that can reach the leaves farthest up in the trees. Now, it's a very simple way to look at it, but not unrealistic at all. Now, biodiversity is the variety of life. If a species or a population has biodiversity, then there is a rich variation in genetic material, diverse enough to survive a challenge, like a disease. Some will be resistant to the disease, others may not. Biodiversity also applies to communities and even entire ecosystems. Now, a community is all the animals that exist and interact in a given place at a given time, like different fish on a coral reef. The fish, the starfish, the coral, the sharks, the octopus, they're all part of the community. The book talks about 6 levels of ecology to consider. You have the individual organism, a population of those organisms, a community of several different populations, an ecosystem, and now we're bringing in the non-living things like rocks and sand, a landscape, which is a whole region of ecosystems that interact, and finally, the biosphere, which is the planet. The book talks about native and non-native species. Figure 3.9 explains how an endemic bird who never had to protect itself from mammals, like a mongoose, evolved to simply make a nest on the ground. But then along comes the introduced species, the mongoose, who finds the nests on the ground an easy meal. The introduced mongoose has disrupted the population, the community, and quite possibly the entire ecosystem. Now, rapid changes requires rapid evolution, but evolution takes time, and it depends on how long each generation is. A human generation is like 70 years. A fruit fly generation can be 24 hours. A virus or a bacteria, the generation can be minutes. So they can evolve very rapidly, and they do. For example, if you look at insects that are evolving to be resistant to pesticides, it happens. Small mutations, the ones that are beneficial, will be passed on to generation. So all around, you can see these systems. They're doing what they do. I want you to enjoy chapter 3 and make note of the definitions you should know, because you don't have to know all of it. And be sure to tab over to chapter 4 and do the same thing, and I'll see you there.